Okay, so today we got a medium problem 3741 minimum distance between three equal elements 2. So we got some numbers, and tuple is good if it's like indices of numbers, distinct indices of numbers of same so it's good if they are indices of same number, and distance of a good tuple is whatever sum of difference first to third and first second and absolute value minimum possible distance of a good tuple if no good tuple is written 1. So we can technically ignore these absolute values because I think that we only care about, of course we can do triplets, and then we can realize like, oh, doing triplets, all triplets is bad, so okay, let's do just triplets that are good. Okay, and then instead now if we rewrite the formula, okay, so now we want to see if we really want to do, because my intuition says we don't do all triplets of same number, we just do adjacent triplets, right? So if like here, if there would be one here, then we would try this, or this, right? Now question is, if we have some order of elements, is it better, because this is like first last, because this is always circular, so you got like the entire circle, but the entire weight, so that's, let's say we have like this, right? And then it's distance between these two, distance between these two, and distance between these two, so it's actually 2 times this. So we try all adjacent triplets of same number and take minimum distance, and the distance is twice of first and third. Okay, so basically we store the indices, so that's like indices default dict int, and int numzi append I guess, and then what? So stinky in this room for some reason. It's weird. Nah, whatever. And now for key value in indices items, and then for I in range ans -1, and then range len v -2, and now distance is vi plus 2 minus vi, and now if ans -1 or d less than ans, then ans technically can be 2 times n, and then ans min ans d return ans. No, so this is a list. Okay, like this. Okay, fair enough. And I mean, we can do this one pass, I think that's the whole point. So if I do ans 2 times n, and then I do if indices like len num xi is over 1, right? Then distance is equal to 2 times I minus nums, like indices num xi minus 2, and then ans means ans d, and then blah blah, right? Like we can do this in one pass. I think that's quite obvious. Okay, let's see how fast this is. That's same speed. Okay. So okay, how big are the numbers? Oh, only n. Problem solved. List. Easy. Okay, that wasn't much faster. It's weird. Yeah, we don't have to store the entire thing because int num xi is equal to int num xi sliced from like -2 to the end plus I think. So this way I can do like 0. Maybe this will be faster, I don't know. Okay, didn't pass all cases. So technically I can straight up just do this. This could be like minus n minus n minus n minus n minus n, right? And then do x here, x in the x like this. Then I can do this and this. What? How is that even slower? That's crazy. So maybe we can do this. What the hell, man? That is crazy. I don't understand. What am I missing? What? What is that solution, bro? What? What? What is that? That's crazy. Let's see some solutions. 100% map based. What? No, nah, brother, nah. Okay. Okay, I'm literally doing that. Okay, whatever. Whatever. Let's submit these and okay, whatever, goodbye. Or not goodbye. I mean, I guess let's write the solution, but I still cannot submit, so who cares? Map on vector. We can the distance is actually just k minus 2 times k minus I. Therefore, instead of checking all triplets of same numbers, check adjacent triplets and pick the find the minimum distance 2 times k minus I approach. Instead of, okay, we can store the last two in this, no, the indices of the last two occurrence of each number, or minus 2n for the occurrences that have not yet been and so that. Okay. Okay. And always and just update them when we encounter a new e.g. we saw number at I and j, and now we see it at k, so we update the answer with 2 times k minus I, and then update occurrences x to jk. Where n is the size of the input, since for each we do O1 calculation and O1 I don't know, O1 no ON, since we have to store occurrences of at most 2 occurrences of at most of ON numbers in the worst case. Okay, goodbye.